Hi, I'm Franny.
I'm Ariam.
I'm Francesca.
And I'm Olivia.
And we're the Saturnity Sisters.
And you're watching How to Pass Your AP Statistics Final
against every single odd.
Jamal is researching the characteristics of a car that might be useful in predicting the fuel consumption rate, FCR. That is, the number of gallons of gasoline that the car requires to travel 100 miles under conditions of typical city driving. The length of a car is one explanatory variable that can be used to predict FCR. Graph 1 is a scatter plot showing the lengths of 66 plotted cars with the corresponding FCR. One point on the graph is labeled A.
Jamal examined the scatter plot and determined that a linear model would be a reasonable way to express the relationship between FCR and length. A computer output from a linear regression is shown below. Part A. The point on the graph labeled A represents one car length of 175 inches and an FCR of 5.88. Calculate and interpret the residual for the car relative to the least squares regression line. Okay, so we know that the residual equals the actual value minus the predicted value, which translates to y minus y hat. And so we're going to take our 5.88 and plug that in for y, because that's the y value of the point, minus a plus bx, and a and b are given to us in the problem, and then x is your x point, which is 175. The residual ends up being positive. It's actually 0.95, which indicates that for a car with a length of 175 inches, which is point A, the regression model has underpredicted its FCR by 0.95 gallons of gasoline per 100 miles traveled. Alrighty, well, in order to get part A right, the College Board says that you need two things. A correct residual value with supporting calculations, so show your work, and number two, a correct interpretation of the residual value in the context in order to earn an E, which is essentially correct.
Jamal knows that it is possible to predict a response variable using more than one explanatory variable. He wants to see if he can improve the original model of predicting FCR from length by including a second explanatory variable in addition to length. He is considering including engine size in liters or wheelbase, the length between axles, in inches. Graph 2 is a scatter plot showing the engine size of the 66 cars plotted with the corresponding residuals from the regression of FCR on length. Graph 3 is a scatter plot showing the wheelbase of the 66 cars plotted with the corresponding residuals from the regression of FCR on length. In Graph 2, the point labeled A corresponds to the same car whose point was labeled A in Graph 1. The measurements for the car represented by point A are given below. Circle the point on Graph 3 that corresponds to the car represented by point A on Graphs 1 and 2. Okay, so to answer this part of the question, on Graph 3, we just need to find the point that has a y value of 0.96, and that would be the point that is currently circled on the graph. There is a point on Graph 3 labeled B. It is very close to the horizontal line at 0. What does that indicate about the FCR of the car represented by point B? So on Graph 3, we can see that point B is very close to the x-axis, and this means that the residual of point B is approximately 0. So the FCR predicted by the linear regression line for car B's length is almost exactly the same as the actual FCR. So according to the College Board scoring rubric, to get an E on this part of the question, which is essentially correct, you must circle the correct point in Graph 3 for the first part, and also provide a reasonable interpretation of the car associated with point B having a residual near 0 that refers to the predicting FCR based on length.
Part C. Write a few sentences to compare the association between the variables in Graph 2 with the association between the variables in Graph 3. So for Graph 2, it's comparing the size of the engine in liters with the residuals of the FCR, and it shows a strong positive linear association. And then for Graph 3, it's comparing the size of the wheelbase in inches, and there seems to be a less positive linear association. Therefore, I think we can conclude that the correlation between the engine size and the FCR is stronger than the correlation between the wheelbase and the FCR. Okay, so to get an E on this part of the question, you need to provide a description of the form, direction, and strength, and include a comparison of both the graphs.
Jamal wants to predict FCR using length and one of the other variables, engine size or wheelbase. Based on your response to Part C, which variable, engine size or wheelbase, should Jamal use in addition to length if he wants to improve the prediction? Explain why you chose that variable. Okay, the answer to problem D is engine size. To improve the prediction, the additional variable needs to be associated to the residuals since the residuals represent the error in the FCR prediction that length does not explain. Since engine size is associated to these errors, engine size can help explain the errors, thus reducing the overall variability in predicting the FCR. To earn an E for Part D, you need to include two components. You need to mention the strong or stronger association, as well as reducing the variability that remains unexplained in the model, which predicts the FCR based on the length.
So we hope with the help of this video and the Fraternity Sisters, you will be able to get a complete response and a score of 4 on this FRQ. Thanks for watching!